Hi, welcome back. In this lesson offered by Simplilearn, you'll learn about the need to integrate Python with Hadoop. In this lesson, you'll understand the need to integrate Python with Hadoop. You'll also get a brief overview of the ecosystem and architecture of Hadoop. You'll see how MapReduce and Apache Spark function and why Spark is increasingly preferred over MapReduce. You'll also learn how to write Python programs to run Hadoop jobs. We have already looked at how we generate big data every day, every second. We have also seen how just having loads of data isn't very helpful unless we start analyzing it and extracting useful information, and how machine learning helps us do this efficiently. Real-time analytics is the rage right now because it helps extract information from different data sources almost instantly so that businesses can make quick data-driven decisions and directly benefit from the system. For example, real-time analytics enable business stakeholders to examine the demographics of their customers to better understand their needs, track shopping trends to build a better inventory, perform sentiment analysis on the data collected from different social media platforms, gather survey reports from customer support, and survey activities for better customer satisfaction and service offerings. This helps them generate higher conversions and revenue by both retaining existing customers and garnering new ones. Conduct targeted marketing based on location, age, gender, interests, and so on. Improve customer satisfaction. Increase sales by setting new goals and roadmaps for the company. However, it gets challenging to perform analytics on huge datasets. This is where Python comes into play with its powerful set of libraries, functions, modules, packages, and extensions. Data scientists all over the world prefer to use Python for analytics because of its ease and support to carry out all the aspects of data science. But to access big data, you have to use a big data platform, which is a combination of the Hadoop infrastructure, also known as Hadoop Distributed File System, or HDFS, and an analytics platform. Hadoop is a framework that allows data to be distributed across clusters of computers for faster, cheaper, and efficient computing. It's completely developed and coded in Java. One of the most popular analytics platforms is Spark. It easily integrates with HDFS. It can also be implemented as a standalone analytics platform and integrated with multiple data sources. It helps data scientists perform their work more efficiently. Spark is built using Scala. Since there is a disparity in the programming language that data scientists use and that of the big data platform, it impedes data access and flow. As Python is a data scientist's first language of choice, both Hadoop and Spark provide Python APIs that allow easy access to the big data platform. Consequently, a data scientist need not learn Java or Scala or any other platform-specific data languages and can instead focus on performing data analytics. There are several motivations for Python big data solutions. Big data is a continuously evolving field which involves adding new data processing frameworks that can be developed using any programming language. Moreover, new innovation and research is driving the growth of big data solutions and platform providers. It would be difficult for data scientists to focus on analytics if they have to constantly upgrade themselves on information or under-the-hood architecture or implementation of the platform. Therefore, it's important to keep the entire data science platform and any language agnostic to simplify a data scientist's job. Consequently, almost all major vendors, solution providers, and data processing framework developers are providing Python APIs. This allows a data scientist to perform big data analytics using only Python, rather than learning other languages like Java or Scala to help them work on the big data platform. HDFS is used to store data in the form of a cluster. In HDFS, the data is split into blocks and distributed across multiple nodes in a cluster. Each block of data is replicated multiple times to increase the availability and reliability of data. Note that the default replication is 3 times. Each replicated block size is mostly 64 megabytes or 128 megabytes. These replicas are stored on different nodes. MapReduce is a data processing framework that runs on HDFS and enables data processing on the cluster. It distributes a task across multiple nodes. Each node processes the data stored on the particular node. MapReduce has 2 phases, namely map and reduce. The task of map is to operate on discrete portions of data, and the task of reduce is to work on the intermediate data that is distributed on nodes.